Hi there! We would be discussing grade 9 science chapter Matter in Our Surroundings. Welcome to our channel. Before we begin, let me tell you the benefit of going through the chapter with us. And it is that when we see and listen to something, our mind kind of registers it without having to make a lot of effort. So, without any further delay, let's begin a super interesting ride of today. First and foremost, what is matter? Anything that has mass, occupies space, and also has volume is matter. Everything in this universe is made up of matter. The air that we breathe, the food that we eat, stones, clouds, stars, plants, animals, even a small drop of water or a particle of sand. Everything is essentially matter. Early Indian philosophers classified matter in the form of five basic elements: the Panch Tattva, air, earth, fire, sky, and water. Modern day scientists have evolved two types of classification of matter based on their physical properties and chemical nature. Let's first see the physical nature of matter. The first question here is, what is matter made up of? To understand that matter is made up of particles, let's first perform an activity. Take a 100 ml beaker, fill half of it with water and mark the level of water. Dissolve some salt or sugar with the help of a glass rod. Does the level of water change? When we dissolve salt in water, the particles of salt get into the spaces between particles of water. Now the second question is, how small are these particles of matter? To understand this, let's perform an activity again. Take 2 to 3 crystals of potassium permanganate and dissolve them in 100 ml of water. Take out approximately 10 ml of this solution and put it into 90 ml of clear water. Now, take out 10 ml of this second solution and put it into another 90 ml of clear water. Keep diluting the solution like this 5 to 8 times. Now, is the water still colored? This experiment shows that just a few crystals of potassium permanganate can color a large volume of water. So, we conclude that there must be millions of tiny particles in just one crystal of potassium permanganate, which keep on dividing themselves into smaller and smaller particles. Let's see a few characteristics of particles of matter. Particles of matter have space between them. When we make tea, coffee, or lemonade, we see that the particles of one type of matter get into the spaces between particles of the other. This shows that there is enough space between particles of matter. Particles of matter are continuously moving. Let's perform an activity again. Put an unlit incense stick in a corner. How close do you have to go near it so as to get its smell? Now light it. What happens? Do you get the smell sitting at a distance? Next activity. Take 2 glasses filled with water. Put a drop of ink slowly and carefully along the sides of the first one. Note what do you observe immediately after adding the ink drops. Add honey in the same way in the second one. What do you observe immediately after adding a drop of honey? Leave them undisturbed for some time. How many hours or days does it take for the color of ink to spread evenly throughout the water? Next activity. Drop a crystal of copper sulfate into a glass of hot water and another containing cold water. Do not stir the solution. Allow the crystals to settle at the bottom. What do you infer from this activity? What do you observe just above the solid crystal in the glass? What does this suggest about the particles of solid and liquid? Does the rate of mixing change with temperature? Why and how? Come on, let's see. Particles of matter are continuously moving, that is, they possess what we call kinetic energy. As the temperature rises, particles move faster. So, we can say that with increase in temperature, the kinetic energy of the particles also increases. In the above three activities, we observe that particles of matter intermix on their own with each other. They do so by getting into the spaces between the particles. This intermixing of particles of two different types of matter on their own is called diffusion. We also observe that on heating, diffusion becomes faster. Now, can you tell us why the smell of hot sizzling food reaches you several meters away? But in order to get the smell from cold food, you have to go close. Let us know in the comment section below. Particles of matter attract each other. The particles of matter have force acting between them, which keeps them together. However, the strength of this force of attraction varies from one kind of matter to another. A diver is able to cut through water in a swimming pool. Which property of matter does this observation show? Let us know in the comment section below. States of matter. Matter around us exists in three different states: solid, liquid, and gas. These states of matter arise due to the variation in the characteristics of the particles of matter. The solid state. Solids have a definite shape, distinct boundaries, and fixed volumes. That is, they have negligible compressibility. Solids have a tendency to maintain their shape when subjected to outside force. Solids may break under force, but it is difficult to change their shape, so they are rigid. What about a rubber band? Can it change its shape on stretching? So can we say that it is a solid? Well, a rubber band changes shape under force and regains the same shape when the force is removed. If excessive force is applied, it breaks. What about sugar and salt? When kept in different jars, these take the shape of the jar. Are they solid? Well, the shape of each individual sugar or salt crystal remains fixed, whether we take it in a hand or put it in a plate or in a jar. What about a sponge? It is a solid, yet we are able to compress it. Why? A sponge has minute holes in which air is trapped. When we press it, the air is expelled out and we are able to compress it. Let's see the second one, the liquid state. Liquids have no fixed shape but have a fixed volume. They take up the shape of the container in which they are kept. Liquids flow and change shape, so they are not rigid but can be called fluid. We saw that solids and liquids can diffuse into liquids. The gases from the atmosphere diffuse and dissolve in water. These gases, especially oxygen and carbon dioxide, are essential for the survival of aquatic animals and plants. The aquatic animals can breathe underwater due to the presence of dissolved oxygen in water. Solids, liquids, and gases can diffuse into liquids. The rate of diffusion of liquids is higher than that of solids. This is due to the fact that in the liquid state, particles move freely and have greater space between each other as compared to the particles in the solid state. Number 3. The gaseous state. Gases are highly compressible as compared to solids and liquids. The liquefied petroleum gas (LPG) cylinder that we get in our home for cooking or the oxygen supplied to the hospitals in cylinders is compressed gas. Compressed natural gas, that is CNG, is used as fuel these days in vehicles. Due to its high compressibility, large volumes of a gas can be compressed into a small cylinder and transported easily. The particles of the aroma of food mix with the particles of air spread from the kitchen, reach us and even farther away. The smell of hot cooked food reaches us in seconds. Compare this with the rate of diffusion of solids and liquids. Due to high speed of particles and large space between them, gases show the property of diffusing very fast into other gases. In the gaseous state, the particles move about randomly and at high speed. Due to this random movement, the particles hit each other and also the walls of the container. The pressure exerted by the gas is because of this force exerted by gas particles per unit area on the walls of the container. If you are liking the video, please don't forget to hit the like button and subscribe for more class 9 science content. Let me ask you a question. Liquids generally have lower density as compared to solids, but ice floats on water. Why? The mass per unit volume of a substance is called density. As the volume of a substance increases, its density decreases. Ice floats because it is less dense than water. Water has a density of 1 gram per cubic centimeter. The density of ice is 0.931 gram per cubic centimeter. The hydrogen bonds that form when water freezes into ice allows the molecules to be spaced farther apart, making them take more space, decreasing the overall density. Hence, the density of ice is less than that of water. A substance with a lower density than water can float on water. Therefore, ice floats on water. Let's understand a few terms. First is rigidity. It is the property which helps a substance to retain its shape when force is applied to it. Solids are rigid, while gases and liquids are not. Compressibility. It is mostly observed in gases. A lot of space between particles. A gas can be compressed to a higher extent. Solids have the least compressibility and liquids have little compressibility because of the least space between their particles. Fluidity. The ability to flow is called fluidity. The less force of attraction and more space between particles makes the liquid and gas flow easily. Fluidity is not observed in solids. Kinetic energy is the energy which a body possesses by virtue of being in motion. It is minimum for solids. They only vibrate at their fixed position. The kinetic energy of particles of liquid is more than compared of solid, but they can slide above one another. The kinetic energy of particles in a gas is maximum. Now we know that solids have a fixed shape. Liquid and gas occupy the shape of the container in which they are stored. This is due to the less force of attraction and more kinetic energy between the particles of liquids and the negligible force of attraction and the highest kinetic energy between particles of gas. Let's try and reason a few things. A gas fills completely the vessel in which it is kept. Why? The particles of gas have negligible force of attraction between them. Hence, the particles are very loosely bound. So, a gas fills completely the vessel in which it is kept. Why does gas exert pressure on the walls of the container? The pressure exerted by a gas is due to the random motion of particles in the gas. Gases have weak intermolecular forces and the particles are in continuous random motion, and these particles collide with the walls of the container. These collisions with the walls of the container exert pressure on the gas. A wooden box should be called a solid. Why? The box has a definite shape and volume. It is very rigid and cannot be compressed. That is, it has a solid characteristic. We can easily move our hand in air, but to do the same through a solid block of wood, we need a karate expert. Why? There is a weak force of attraction between the particles in air. So, we can move our hands in air whereas the particles in solid plank are closely packed and a strong force of attraction exists between them. Hence, it needs a huge force to overcome the attraction which a karate expert can do. Now, a rather good question is, can matter change its state? And if it can, how does this change of state take place? What happens inside the matter during this change of state? What happens to the particles of matter during the change of states? We need answers to these questions, isn't it? Solids to liquids. Have you ever accidentally left an ice cream out of the freezer in summers? What happened with it? It melted, right? But why? On increasing the temperature of solids, the kinetic energy of the particles increases. Due to the increase in kinetic energy, the particles start vibrating with greater speed. The energy supplied by heat overcomes the forces of attraction between the particles. The particles leave their fixed positions and start moving more freely. So, particles in water at 0 degrees Celsius have more energy as compared to particles in ice at the same temperature. A stage is reached when the solid melts and is converted to a liquid. The minimum temperature at which a solid melts to become a liquid at the atmospheric pressure is called its melting point. The melting point of a solid is an indication of the strength of the force of attraction between its particles. Do you know what is the melting point of ice? Let us know in the comment section below. The process of melting, that is, change of solid state into liquid, is also known as fusion. When a solid melts, its temperature remains the same. So, where does the heat energy go? The heat gets used up in changing the state by overcoming the forces of attraction between the particles. As this heat energy is absorbed by ice without showing any rise in temperature, it is considered that it gets hidden into the contents of the beaker and is known as the latent heat. The word latent means hidden. The amount of heat energy that is required to change 1 kilogram of a solid into liquid at atmospheric pressure at its melting point is known as the latent heat of fusion. Liquids to gases. When we supply heat energy to water, particles start moving even faster. At a certain temperature, a point is reached where the particles have enough energy to break free from the forces of attraction of each other. At this temperature, the liquid starts changing into gas. Boiling point is the temperature at which a liquid starts boiling at the atmospheric pressure. Boiling is a bulk phenomenon. Particles from the bulk of the liquid gain enough energy to change into the vapor state. For water, this temperature is 100 degrees Celsius. Now again, particles in steam, that is water vapor at 100 degrees Celsius, have more energy than water at the same temperature. This is because particles in steam have absorbed extra energy in the form of latent heat of vaporization. Latent heat of vaporization is the amount of heat needed for the conversion of 1 kilogram of liquid at its boiling point to gas at the same temperature. Thus, the states of matter can be changed into another state by changing the temperature. A quick question. What would be the state of water at 250 degrees Celsius? Let us know in the comment section below. Also, there are some things that change directly from solid state to gaseous state and vice versa without changing into the liquid state. Let's understand it with an activity. Take some ammonium chloride, crush it and put it in a china dish. Put an inverted funnel over the china dish. Put a cotton plug on the stem of the funnel. Now heat it slowly and observe. The ammonium chloride changes directly from solid to gas. A change of state directly from solid to gas without changing into liquid state is called sublimation. And the direct change of gas to solid without changing into liquid is called deposition. We have seen the effect of change of temperature on the state of matter. Do you think that increasing or decreasing the pressure can change the state of matter too? What will happen when we start putting pressure and compress a gas enclosed in a cylinder? Will the particles come closer? Yes, by applying pressure, particles of matter can be brought close together. Applying pressure and reducing temperature can liquefy gases. Do you know what dry ice is? Well, it is solid carbon dioxide and it has to be stored under high pressure. Solid carbon dioxide gets converted directly to gaseous state on decrease of pressure to 1 atmosphere without coming into liquid state. This is the reason that solid carbon dioxide is also known as dry ice. Applying pressure and reducing temperature thus can liquefy gases. Do you wonder how do wet clothes dry up? Evaporation. Also, water, when left uncovered, slowly changes into vapor. How? Evaporation. Again. We know that particles of matter are always moving and are never at rest. At a given temperature, in any gas, liquid, or solid, there are particles with different amounts of kinetic energy. In the case of liquids, a small fraction of particles at the surface having higher kinetic energy is able to break away from the forces of attraction of other particles and gets converted into vapor. This phenomenon of change of a liquid into vapors at any temperature below its boiling point is called evaporation. So let's understand the factors that affect evaporation. Let's perform an activity. Take 5 ml of water in a test tube and keep it near a window or under a fan. Take 5 ml of water in an open china dish and keep it near a window or under a fan. Take 5 ml of water in an open china dish and keep it inside a cupboard or on a shelf. Record the room temperature and record the time or days taken for the evaporation process in the above cases. Also, repeat the above 3 steps of activity on a rainy day and record your observations. You must have observed that the rate of evaporation increases with an increase of surface area. We know that evaporation is a surface phenomenon. If the surface area is increased, the rate of evaporation increases. That is why, while putting clothes for drying, we spread them out. An increase of temperature. With the increase of temperature, more number of particles get enough kinetic energy to go into the vapor state. A decrease in humidity. Humidity is the amount of water vapor present in air. The air around us cannot hold more than a definite amount of water vapor at a given temperature. If the amount of water in the air is already high, the rate of evaporation decreases. An increase in wind speed. It is a common observation that clothes dry faster on a windy day. With the increase in wind speed, the particles of water vapor move away with the wind, decreasing the amount of water vapor present in the surroundings. How does evaporation cause cooling? In an open vessel, the liquid keeps on evaporating. The particles of liquid absorb energy from the surrounding to regain the energy lost during evaporation. This absorption of energy from the surroundings makes the surroundings cold. When you pour some acetone or nail polish remover on your feet, the particles gain energy from your feet or surroundings and evaporate, causing the feet to feel cold. After a hot sunny day, people sprinkle water on the roof or open ground because the large latent heat of vaporization of water helps to cool the hot surface. Why should we wear cotton clothes in summer? During summer, we perspire more because of the mechanism of body which keeps us cool. We know that during evaporation, the particles at the surface of the liquid gain energy from the surroundings or body surface and change into vapor. The heat energy equal to the latent heat of evaporation is absorbed from the body, leaving the body cool. Cotton, being a good absorber of water, helps in absorbing the sweat and exposing it to the atmosphere for easy evaporation. Why should we wear cotton clothes in summer? That we have understood. Now, why do we see water droplets on the outer surface of a glass containing ice cold water? This is because the water vapor present in air, on coming in contact with a cold glass of water, loses energy and gets converted to liquid state, which we see as water droplets. Do you know why does a desert cooler cool better on a hot dry day? If the amount of water vapor present in air is less, then evaporation is more. Now, on a hot dry day, the amount of water vapor present in air is less. Thus, water present inside the desert cooler evaporates more, thereby cooling the surroundings more. That is why a desert cooler cools better on a hot, dry day. How does the water kept in an earthen pot or matka becomes cool during summer? An earthen pot has a large number of tiny pores on its body. Hence, a small amount of water seeps out from these pores and gets evaporated from the surface. Hence, the water inside the earthen pot keeps losing heat, thus remaining cool. Thus, water kept in an earthen pot or matka becomes cool during summer. Why are we able to sip hot tea or milk faster from a saucer rather than a cup? The more surface area, the faster is the rate of evaporation, right? Since the surface area is more when tea or milk is in the saucer as compared to that when tea or milk is in the cup, the rate of evaporation is faster in a saucer. Hence, we are able to sip hot tea or milk faster from a saucer rather than a cup. Well, this was fun, wasn't it? Please don't forget to hit the like button. Do you know that now scientists are talking of 5 states of matter? Solid, liquid, gas, plasma. Plasma, the state consists of super energetic and super excited particles. These particles are in the form of ionized gases. The fluorescent tube and neon sign bulbs consists of plasma. Inside a neon sign bulb there is neon gas, and inside a fluorescent tube there is helium gas or some other gas. The gas gets ionized, that is, gets charged when electrical energy flows through it. This charging up creates a plasma glowing inside the tube or bulb. The plasma glows with a special color depending on the nature of the gas. The sun and the stars glow because of the presence of plasma in them. The plasma is created in stars because of very high temperature. And the last one is Bose-Einstein condensate. In 1920, Indian physicist Satyendra Nath Bose had done some calculation for a 5th state of matter. Building on his calculations, Albert Einstein predicted a new state of matter, the Bose-Einstein condensate. In 2001, Eric A. Connell, Wolfgang Ketterle and Kali Wieman of USA received the Nobel Prize in Physics for achieving Bose-Einstein condensation. The BEC, as it is popularly known, is formed by cooling a gas of extremely low density, about 100,000th the density of normal air, to super low temperatures. So guys, that was matter in our surroundings. Hope you liked the video. Don't forget to like, share and subscribe. And until next time we meet, keep learning, keep growing and make healthier choices and be kind to people you meet. Bye bye, have the greatest day. Good luck.